use formula V square over R. V is the voltage drop across 3 ohm. R is 3 ohm. If we use P is equal to IV, so I is the current flows through 3 ohm and V is the voltage drop across 3 ohm. Someone has recorded it, right? Okay. Okay, today, okay, any question regarding recurrent divider, voltage divider? I have posted Microsoft. I have posted form in Microsoft Team. Okay, it is your attendance for this week for the other slot. Okay, for the other slot. So submit by 12 p.m. this Friday. So make sure you submit your response according to your class. Okay, if you are BKG S1, so you submit here. If you are BKG S2, so you submit here. Do not please use your own platform. Okay. Okay, so next we go to other example. Okay, so I hope you have watched my video and go through nodal analysis in PowerPoint slide. So today I just want to give more examples on nodal analysis. Okay, so this is tutorial 2 number 30. Use node analysis to calculate current I1 through I4. So you have to find I1, I2, I3, and I4. Okay, the first step is to assign node. Okay, so this circuit has 2 nodes. Okay, V1 here and this is V2. Okay, we name it as V1 or V2, or you can name it as VA, VB, VS, VY, up to you. Okay, actually at the bottom is another node. It is ground node. Okay, but the V is equal to 0 volt, so we just put for V1 and V2 only. Okay, because the voltage at the ground is equal to 0 volts. Okay, so any question up to here? No? Okay, so the first step is to assign V1, V2, V3 and so on, okay? At each node, okay. And then the second step is to assign arrow of current at each branch, okay? So at this branch 4M, we just follow the arrow of 4M. Okay, this 4M enter this node. So just follow this node. Just follow this arrow. Okay, and then, okay, so in this question, you no need to assign the arrow for each current because it has been provided by the question. Okay, I1 go to ground, I2, I3 and I4 go to ground. Okay, so after, okay, if the question did not assign arrow of current, okay, as well as the current itself, meaning that I1, I2, I3 and I4, so that you have to put the flow of, the arrow of current at each branch. Okay, and then the next step is to write KCL equation at each node. Okay, so this is KCL at V1. Okay, so KCL at V1, and then we have to write equation for V2. Okay, so we have 2 nodes here, meaning that we will have 2 KCL equation. Okay, to find two unknown voltages, it is V1 and V2. Okay, so KCL at node V1. Okay, this is current entering the node. Okay, we have I1 leave the node and I2 leave the node. These two enter the node. So we have four branches here, meaning that we will have four items in the KCL equation at V1. Okay, what are the currents enter the node? We have 4 and we have 2. So 4 plus 2 is equal to, what are the currents leaving the node? So we have I1 and I2, so I1 plus I2. Okay, any question up to here? Actually, my sometimes my PowerPoint and Microsoft Word has problem. Okay, always hanging. Okay, so any question up to here? Any question? No question? Say no or type no here.
No, we understand.
Okay, so the next step is to substitute. Okay, so remember that in KCL equation, each term is current. Okay, current enter the node is equal to current leaving the node. Okay, so each item is current. So now the next step is to substitute that current with Ohm's law. I is equal to V over R. Okay, so 4 plus 2 is equal to 6. I1 and I2 here. Okay, and then now you substitute I with Ohm's law. Okay, I is equal to V over R. So I1 is here. I1 is the current flows through 5 ohm, meaning that V drop across 5 divided with 5. Voltage drop across 5 is V1. Okay, so V1 over 5 plus I2 is V1 divided with 10. Okay, the voltage drop across 10 is V1 as well, because 5 and 10 share the same node. There are parallel. Okay, so the voltage drop across 5 is same as the voltage drop across 10. Okay, the same node here. Equal to 6. Now we solve this and we get V1 is equal to 20 volts. Any question? If no, say no, type no.
I understand and notice.
Good, Philip. Okay. Okay, so same goes for V2. Okay, now we apply KCL at V2. What are the currents entering the node? 5. 5, right? Okay, so 5 is equal to currents leaving the node. Okay, we have 2, I3 and I4. Okay, now we rearrange I3 plus I4 is equal to 3. We substitute each I in this equation with Ohm's law, it is I equal to V over R. So I3 is equal to V2 over 10. I4 is equal to V2 over 5. Okay, and then we solve for V2 and we get 10 volts. And then now it's time to find current I1 through I4. So I1 is equal to this V1 over 5, V1 over 5. Okay, so 20 over 5 we get 4. Same goes for other current. Okay, any question? Can understand? Say yes or type yes.
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 Good. This is very basic example. Okay, this is taken from textbook. Find current I1 until I4 and voltage V0. Actually, if the question did not mention what method, so up to you. You can use any method that you know. Okay, so you can choose any method that is simpler, and provided that you have information, you have data to use that formula. Okay, so if we look at this figure, okay, at the top of the figure, okay, is only one node here. Only one node here, okay. All branches share one node at top and bottom, okay. So it is easier to solve this question using nodal analysis, okay. If the question mention the method, okay, let's say find currents by using nodal analysis, so you must use that method. You must use nodal analysis. Otherwise, no mark, or mark will be deducted, okay. So if the question did not mention any method, so just use any method that you know, okay. So we have only one node at at top, okay. So let's name it as V node. Okay, no. This question specify the node as V node. So just use V node. Do not replace with V1, V2, Vx, Vy. Okay, just use V node. Okay, so now we apply KCL at the node. KCL. Okay. So what are the currents enter the node? What are the currents entering the node? Please answer. You can speak and you can write. What are the currents entering the node?
Entering the notice.
A.
Yeah.
Okay. Yeah. Only A. Good. Okay. So, what are the currents leaving the node? Farid, Wajid. What are the currents leaving the node? Farid? Give the name of the current.
Give the name of the current.
All the currents that leave the node. Farid?
Yeah, yeah.
What are the currents leaving the node?
Yang 28 tu.
Just now I asked what are the current enter the node, okay? So the answer is 8. Now what specify the currents leaving the node? Cepat Farid. Kejap.
Saya rasa 20A.
Sekejap.
Betul.
Oh, okay. Maaf ya. Saya kena sini. Nanti saya jelaskan ni. Kalau saya bila nanti saya search lah. Cik, sorry ya, saya jelaskan. Okay. Okay. Farid.
Betul, saya rasa I1, I2, I3.
I1, I2, I3. That's all. Any
Saya
other
rasa
current? Okay, all except 8M, okay? Exactly,
everything.
all except 8M. So Farid, please answer again. What are the current leaving the node?
I1, I2, I3.
I1, I2?
I3.
Please observe again. Afiq give you the answer.
Dengan I4.
So I1 plus I2 plus I3 plus I4 plus 20 as well, okay, equal to A. Okay, and then we substitute each I in the equation with Ohm's law. I is equal to V over R. I1 is equal to V0 over 10. Okay, and then V0 over 20 for I2, I3 V0 over 30, I4 V0 over 60 equal to minus 12 here. Okay, and finally we get V0. Okay, so we have V0 and then I1 until I4, just substitute V0 in each term and we will get the answer. Okay, any question? If no, say no, type no.
No, so
Good.
far.
Okay. Okay, good, Wafi. Okay, Alamin. Okay, next question. Okay, still basic question. So obtain V0 in the circuit. Okay, so V0 is here. V0 is located here. So how many nodes is needed in this circuit? How many nodes? How many nodes?
Looks
How
like
many?
just one.
Just one. Just one. Who answered that, Philip?
Yes.
Okay, how about Afi? Please specify V. Okay, where is the two nodes? Afi,
The below one
here.
that connect to K ohm, 5K ohm, 4K ohm.
Okay, so the node is grounding. Okay, so at ground, at the ground. Okay, actually we have grounding here. Here V ground is equal to 0 volt. Okay, so yes, your answer is right. Okay, but since we know that V here is equal to 0 volt, so we no need to find it again, right? So now we just have only one node here. Okay, let's name it as V naught because it's same as notation here, V naught. V naught is equal to the voltage drop across 4K ohm. Okay, but it is not the voltage drop across 5K and 2K because at these two branches there are another voltage source. Okay, so now we apply KCL at the node. Okay, so KCL at V0. Okay, so the next step is to specify the arrow of current, the flow of current. Okay, since in this question, the question did not specify the current, the arrow of current, so up to you. You can decide by yourself. Okay, so let's say at this branch, you can put the current to flow out from the node or enter the node, up to you. Okay, same goes for other branches, but the equation will follow the arrow of current. Okay, the equation will be different, but the final answer will be the same. Okay, so let's say I put all the currents flows out from the node V0. Okay, so I put this is I1, I2 and I3. So I1, I2, I3 is equal to 0. Okay, all the currents leave the node is equal to 0. 0 means that no current enter the node. Okay, so now let's substitute each I with Ohm's law. Ohm's law is I is equal to V over R. Okay, so I1 is flows from V0 until ground. Okay, actually, so if you put I1 flows from V0, so I1 is equal to V0 minus, okay, we have voltage source here, positive 30 volt, so V0 minus 30. Okay, actually we have minus 0 here. Why? Because okay, actually this one we not here, we have positive and negative 30 volt here, and then we have this is ground, we have 2k ohm. Okay, so current flows from V0 until ground, right? So this is I1. So I1 actually is equal to V0 minus 30 minus 0 divided with 2k. Okay, but you can ignore 0 because we know that anything minus 0 is it seems like you write like this, V0 minus 30 only. Okay, divided with 2k. And then plus I2, I2's flow from here. So same principle, V0 minus, this is positive 20 volt, right? V0 minus 20 divided with 5k. Actually, this term also we should minus with 0. Okay, but we can ignore that. Okay, okay, you can write or you can ignore. And then plus I3, V0 minus, okay, no voltage source. Actually, this one is V0 minus 0 volts, okay. But you can write, you can ignore 0 because 0, and then divided with 4k. Now we solve for V0 and we will get V0 is equal to 20 volts. Any question? If you have question, please ask today rather than asking me during weekend at night.
Doktor, kalau macam yang voltage source tu 30 volts and 20 volt tu, so we know that current is normally going out from positive terminal, right? So can we assume that the current for I1 is entering the V nodes and the 20 volt, and current from the 20 volt is entering the V node also?
Boleh, yes, you can, but the equation will be 30 minus V0 divided with 2k. This one 20 minus V0 divided with 5k. Okay, so the voltage difference is from where the current flow. Okay, so meaning who asked the question? Afiq.
Yes.
Afiq, okay, so Afiq want to make the I1 flow from 30 volt to V0, so 30 minus V0 divided with 2k, okay, and you will get the same answer. Okay, now you can try. Okay, you can try. You can try. Okay, to put I1, enter the node, and this one is I2 here. I2 also enter this node, okay? But your equation will be I1 plus
I2 equals to I3.
yes. Okay, you may try. I1 plus I2 is equal to I3. So I1 is equal to 30. Here is 30 minus V0. Okay. Divided with 2k. And then plus I2 is equal to 20 minus V0. Okay. And then equal to I3. I3 is equal to V0 divided with 4K. Okay, and then please rearrange. Make sure you get the same answer. Okay. Get the same answer?
Yes, we got the same answer.
Okay, consider that you get the same answer. How about everyone? How about others?
This method has a lot of decimals.
Okay, got the same answer, right?
Yes,
Okay.
we still get the same answer.
Okay.
But the process, there's a lot of decimal. It is a little bit complicated.
Okay, so up to you. You can assign the arrow of current. Enter the node or leave the node, up to you. Okay, but your equation must follow the flow of current. Okay, must obey KCL. Okay, now we go to other example. Solve for V1. V1 is here. Okay, so now V1 is the voltage drop across 10. So since this is V1, so I put the node here as V1. Okay, because V1 here is same as the V1, the V across 10. Okay, so I make this resistors parallel, so it becomes 10/3. So we apply KCL at V1. Okay, current and all current flows from the node I1 plus I2 plus I3 is equal to 0. I1 is equal to V1 minus 10 divided with the resistor here. Okay, 10/3 plus V1 over 10, and then plus V1 minus 20/4. Okay, solve for this equation and you will get this answer. Any question? No, right?
Got none here.
Sorry?
No questions so far.
Okay, so this is the next. Okay, we are still um, calc we are still calculating a very basic question. Okay, apply nodal analysis to solve for VS. VS is here. How many nodes? How many nodes here?
One node.
No, okay. Because all branches share the same node at the top. Okay, so let's name this node as Vx. Okay, because we find that Vx is the voltage drop across 20, and it is same as the voltage at this node. So just name it as Vx. Okay. The next step is to assign flow of current. Again, up to you. Okay. You can make it enter the node, you can make it leave the node. Okay, so I always make the current to flow to ground. Okay, meaning that flow to ground, this is ground. Okay, so how many nodes enter the node? We have 2 M. Okay, so 2 only, 2. So and other currents leave the node. We have I1, I2 and 0.2 Vx. Okay, so I1 plus I2 plus 0.2 Vx is equal to 2. Okay, now we substitute each I with Ohm's law. I equal to V over R. So I1 is equal to Vx over 10, I2 is equal to Vx over 20 plus 0.2 Vx equal to 2. We solve for Vs and we will get this answer. Okay, Vx is equal to this. So far okay, right? Any question? Please say no. or yes?
Oh, no
No.
question.
Good. Okay. This is another example, but this is the question that you need to answer in Microsoft in form. Okay. That will be recorded as your attendance for another one slot. Okay. So luckily you have answer here. So if you get the answer same as this, so consider that your answer is right, provided that your flow of calculation is correct. Okay. So do it yourself. So you must use nodal analysis. Next is this question. Using nodal analysis, find IB. IB is the current flows at this branch. Okay. So how many nodes here? How many nodes?
Just one is one.
Tan Li Zong, how many nodes?
1.
One. Tan Li Zong, please answer. How many nodes do you think? 1 or 2 or 3? 1. Okay, so the answer is 1 only here. Okay, so I name the node as V1. Okay, so find IB. IB is here. So now we have to find V1 first. Okay, so at V1, okay, so the next is to assign flow of current. I just make the current flows to ground. So I1 here, I2 here. Okay, KCL at V1. Current enter is IB. Okay, IB. Current leave the node is I1 and I2. And we substitute each I with Ohm's law. IB is current flows through 250. Okay, it's flow from this to V1. Okay, so 24 minus V1 divided with 250. Okay, if you want to make current here leave V1, not V1, yes you can, but finally that current is equal to minus IB. Okay, or IB is equal to minus that current. Okay, so we substitute IB. IB is 24 minus V1 divided with 250 is equal to I1. I1 is the current here, V1 over 50 plus I2. I2 is here, V1 minus 60 IB divided with 150. Okay, actually this is series path. You can put 150 anywhere at this branch. Okay, same goes for this water source. You can put this, you can rearrange this water source, you can put here, okay, up to you. Okay, or just leave as it is. Okay, now we have V1 and we have IB here. We should substitute IB with term of V1. Okay, so that you can solve your equation. Okay, we know that IB is this 24 minus V1 over 250. Okay, now we substitute IB with this. Okay, and then expand, and finally you get V1 is equal to this. Okay, and IB substitute V1 in this term and you will get IB. Any question? No. Okay, I think this is the last example. Actually, in your tutorial, this is number 26. Last week, I have discussed this question with BEKM student. Actually, okay, this question use star delta transformation. Okay, in number 26. This question is in tutorial to this question is number 26. Okay, it is arranged before nodal question. Okay, So actually we solve this question using star data transformation. We transform this delta to star. Okay, and then finally we solve V by using current divider or voltage divider. Okay, now we also, since the question did not mention certain method to solve for V, let's use nodal analysis. Okay, how many nodes? Siti Maisara, how many nodes? If you look at this figure, how many nodes? If you use nodal analysis?
2.
2. Is it enough?
No, 3.
3. Okay. So I name the node as V1, V2, and V3. The next step is to assign flow of current at each branch. Okay. So you may do it differently. Okay. But make sure that once, okay, let's say I4. Once you put I4 leave node V1, it must enter V3. Okay. So make sure that if do not make I4 leave V1 and then at V3 I4 also leave V3. Cannot. Okay. So must be consistent. If you put I4 flows from V1, so it must enter V3 here. Okay, so now you can decide by yourself how to assign the flow of current, up to you, because your KCL will follow that flow of current. So at V1, I1 is equal to I2 plus I3 plus I4. I1 is equal to 100 minus V1 divided with 16. Okay, equal to I2 is equal to V1 over 35. I3 V1 minus V2 over 15. I4 V1 minus V3 over 30. Okay, and then please rearrange your equation, V1 followed by V2 followed by V3 equal to round number. Okay, if there is no round number, so it's equal to 0. And then we write KCL equation at V2. I3 current enter. Okay, is equal to current leaving the node I5 plus I6. Okay, substitute I3. So I3, okay, we have I3 here, V1 minus V2 over 15. It is equal to I5, V2 divided with 12 plus I6, V2 minus V3 divided with 10. Please rearrange, okay, in terms of V1 followed by V2 followed by V3 is equal to round number. Okay, if there is no voltage source at the node, so equal to 0. Okay, and then at V3, current enter is I6 and I4. Okay, current leave the node is equal to I7. Substitute I7 is equal to V3 over 20, I4 is equal to V1 minus V3 over 30, I6 is equal to V2 minus V3 over 10. Rearrange. Okay, start by V1 followed by V2 and V3 is equal to round number. Okay, and then use your calculator. You know how to use your calculator, right? If you watch my video, if you follow my PowerPoint slide, I guide you how to solve equation using calculator only, right? Okay, so make sure that you key in the constant correctly. Okay, let's say for this term, you must key in your calculator minus 1 over 15. Okay, at the end you will get V1 is 42.2, V2 is I do not display the V2 here, and then V3. Okay, you will get V1, V2, V3. Okay, why I just put V1 here? Because our target is to find V here. Okay, V is equal to V1. Okay, so any question?
Doktor,
Hmm.
kalau dapat soalan macam ni, kita perlu buat Y delta ke ataupun biarkan je?
Okay, now the question did not mention any method, okay? Did not specify any method to solve for V. So up to you. If you want to use star delta, okay, you can solve by using star delta, okay, and then after you have star delta, you will solve by using current divider, voltage or voltage divider, right? Where is the equation? Okay, this is star delta. Okay, this one. Okay, actually, at this moment, we do not learn nodal analysis. Okay, and question number 26 in tutorial 2 is actually for star delta, current divider, voltage divider. Okay, so that's why at this moment we solve using star delta. Okay, we transform this delta to star, and then we use current divider, voltage divider. Okay, this one is voltage divider, or you can use current divider. Okay, and finally you get the answer 42.18. Okay, this is the method of star delta and voltage divider, right? Okay, star delta and then voltage divider. Okay, if you want to use nodal, so just do like this. So up to you. You can decide by yourself. If the question did not specify any method, certain method, so up to you. You can decide. Actually, you can use, if you learn mesh analysis, you can solve this question by using mesh analysis. But it will be more complex, okay? Complex. So, up to you. Okay. Who asked just now?
Nasrin.
Nasrin, am I answering your question? Terjawab?
Yes.
Okay. So Nasrin
Yes.
want to use what method?
Just let it be macam mana soalan ni je lah. Tak payah buat mesh, tak payah buat Y delta.
I prefer nodal analysis, okay, compared to solving for Y delta Y. Okay, up to you. Sometimes student quite confused with nodal analysis, okay, because you must be very careful, okay. If you do mistake on minus, positive, plus, minus here, okay, then your final answer will be wrong, okay. So in nodal analysis, it is interesting, but you must put more, you must be very, very careful, okay. And you should type, or you should key in your number in calculator very, very careful, okay. You must be very careful, okay. Any question? No question? I think this is our last slide. Our last slide before we, okay, so this is the guide how to key in your equation in calculator, okay. Any question? If no questions, type no, say no, so that we can end our session.
Doktor,
Hmm.
boleh tengok soalan tutorial nombor 29 tak?
Tutorial nombor 29. Mana Dua sembilan macam nampak tadi. 32, 33. Mana? Sekejap Okay.
Kan ada dua note.
Hmm.
Lepas tu doktor kata kita boleh decide mana-mana arah untuk current.
Yes.
Kalau I want to masuk ke kanan, I3 ke atas, I2 ke bawah dan I6 tu ke 6 lah kan. Still akan dapat jawapan yang sama kan?
Of course. If you make I1 flow from ground to V1, right? Kan?
Tapi saya tak dapat jawapan yang sama.
You will get the same answer. So the answer for this is
12 and 0 votes.
12-0.
Yes.
Okay, let's say all currents goes from V1, so it be like this. Okay. Now please rearrange. So this is your first equation. Okay. At V2, V1 minus V2 divided with 2 plus 9 equal to V2 divided with 4. Right? Rearrange.
V1 minus V2 tu tak kisah. Kalau V2 minus V1 pun boleh jugalah pasal kita tak tahu yang mana satu nilai paling tinggi kan.
Cannot. Okay.
Cannot. Then
Because
how-
at V1 you make the current I3 flows from V1 to V2. Okay. So at here, this I3 must enter V1. V2.
So it depends on the what direction current that we assume to. Is it?
Yes, depend on your direction of current.
But based on the notes so kan, it say V1 is node 1, V2 is node 2. So by right at node V1 tu akan ada four different current lah, which is entering and leaving, is it? Bukan ke?
I3, okay, at this branch, we have only one current. It is I3. Okay, I3.
No, dekat node V1 tu, supposedly tu kan node dia kan ada 4 branches, right?
Yes.
So by right dia ada 4 current lah yang
Yes.
datang, betul?
Yes.
So current yang ke arah current source 6M tu, itu berapa? Current yang ke situ daripada V1 tu.
This one is 6 at this branch. This one is 6.
So current coming out from V1 punya nodes tu is 6 A.
You mean, okay, 6 A flows from V1 to V2. Okay. 6 A flows. Okay, we just follow this flow of current. Okay, just follow this arrow. So 6 flow from V1 to V2.
So kalau based on your annotation tu, which is I1 going out, I3 going up, I2 going down kan? So dia punya equation tu, persamaan dia dekat node tu is I1 plus I2 plus I3 plus 6M equals to 0.
Yes.
Okay. So same macam yang dekat point V2 tu lah.
At V2, 6 plus I3 plus 3 equal I4.
Oh, okay. Alright.
Now, everyone please calculate. So V1 is equal to berapa? Sorry. 12. V1 is equal to 12 volt and V2 is equal to V1 is equal to 0, right? Am I right?
Sepatutnya macam tu lah jawapan dia. V1 0, V2 12.
Okay. So now you want to try to make I1 flow from 0 to V1, right? Tadi siapa Betul tak? Okay, now we put let I1 flow like this. Can flow like this. So okay, so I1 is equal to minus minus V1 minus V1 over 10 because 0 minus V1 over 10. Okay, equal to this. Equal to V1 over 5. Okay, and then plus, okay, this one is plus 6 plus this one is V1 minus V2 over 2, V1 over 5, okay, like this. Okay, class. Any question?
Doktor, Kena guna semua resistor ke? Tak boleh I3, I2 dengan 6 je? Kena I1 sekali
Of course. Okay. Who's speaking just now?
Nasrin.
Okay. So you can change the direction of current, but your KCL equation will be different. Okay. And then your subsequent calculation will be the same. Okay. Okay. At V2, okay, now we check for, okay, so this is the equation at V1, okay, and then we simplify, it will be the same. Okay, at V2, current enter is, okay, so at V2, I1 is not involved with V2, okay. At V2 we have I3, this is I3, okay, and then we have 6, we have 3, and then we have I4, okay. The rest is the same. Okay, Nasri, any question?
Okay.
Hmm.
Doktor,
Yes.
boleh tak nak tanya tentang soalan Y delta?
Sekejap. Y delta. Kenapa?
Tutorial 21.
21. Kena buka tutorial ni Sekejap Okay. Why?
Doktor macam mana nak kira sebab saya dah convertkan yang delta tu kepada Y. Tapi saya tak reti kira.
Which one delta? Which delta?
The middle one.
Ni. This question.
Yes.
Okay. Now I want to ask your friend. Okay, how to solve this question? Please answer or write here. How to solve this question?
No idea, Doktor.
Yeah, no idea. Afiq. Philip, how to solve this question? How to find R equivalent? How to find R equivalent first?
R equivalent for, you mean the whole R right here, the whole
Yes.
circuit
Okay. Yes.
resistance.
Yes, the total resistance. How?
If I use the way that I know, we need to simplify the circuits first. We need to rearrange the circuit itself, and it's a little bit complicated to explain this because there's a lot of resistors over there.
Just speak. This is this question is not very difficult. This is
No,
not
not
so
really.
not so difficult. Okay. Any other opinion how to solve for R equivalent? Can you see my screen?
Yes, we can see it.
Okay. How to solve this? Akif Asmawi. How to solve? Akif? Are you with me, Akif Asmawi? Habib, want to share something?
Actually, I'm not sure.
You want to try?
I'm not sure. I don't have idea.
Habib, where is your hometown? You're an international student.
Yes.
Oh. Correct. Actually, that question is on only series and parallel. No need to use star delta. 21.
No, there isn't any actually.
21, okay? 21. Series parallel. 21. Okay. This is no 21, 21. This is the solution. Tadi siapa tanya tadi? Nasrin.
Nasrin.
Nasrin, this is the solution, Nasrin. No need to solve by using star and delta. Okay, class, before you decide to use star and delta, the first step is to find whether the connection, there is connection of series and parallel. If we can solve for series and parallel only, why just use series and parallel, no need star delta, because if you use star delta, it will be more complex, okay, more steps. So why does we use series and parallel? Yes, if you use star delta, yes, you will get the same answer, okay. But if there is no need to use star delta, so do not use star delta, just solve for series and parallel. Winston, I don't know, your friend can see my screen. Simplify the circuit. Okay, so Nasrin, can you understand this calculation? We just make
Yes.
80 and 20 parallel, 12 and 6 parallel. Okay, and then if you become like this, series this, and then make this and 60 parallel, as well as 15 parallel, and then add with 5. Okay, any other question?
No, Doctor.
Okay. Okay, let me re-share my screen after this. No question? I have downloaded your attendance for today. Okay, no question. So no question?
Philip.